excited.
Okay, great. You should have the ability to share your screen.
My screen sharing.
Let me see if I can change that. Advanced screen sharing. Okay, give it a try.
Okay. Great. Okay, can everyone see that?
Sure can. Yep, you
All
might
right.
want to maximize it so we can, yeah.
Okay. So, hello, I am Ray Jackson, and my project is Augmented Reality Biofeedback and Effects on Stress, Mood, and Measures of Memory Encoding. I had the pleasure to work with Leah Frank and Dr. Dasha Zaitamova of the Brain and Memory Lab. So it's well known that a brief meditation experience reduces feelings of stress and anxiety. So it's not surprising these experiences are reflected in virtual reality meditation applications. When these applications are combined with biofeedback, we've also seen stronger effects. Additionally, other studies have shown reductions in stress can facilitate improved performance on cognitive tasks. Augmented reality, which is different from virtual reality in the way that it's less of a break with the real world, paints images, virtual images on top of real world scenery through applications like smartphones. So little research has been done on this, and no research to date has examined the ability of a brief AR meditation to boost cognitive performance. So we asked, can AR-based meditation experience stimulate a temporary boost in cognition, specifically memory encoding, because we're the Brain and Memory Lab, by way of lowering stress? We also wanted to examine any mood effects by adding biofeedback. We had 9 participants who were undergraduate students at the University of Oregon. Unfortunately, due to the COVID-19 crisis, we only got a week's worth of collection, but we hope to pick up again in the future. Our 2 intervention groups were our biofeedback group, where our subjects, through the screen of a smartphone, saw a tree painted on top of the room in front of them, where they viewed their heart rate, and they used a guided breathing technique from the application to keep their heart rate low. In response to their heart rate, the butterflies would hatch from the AR tree and fly around the room. So the lower the heart rate, the more butterflies. Our other group is a non-biofeedback group who saw the exact same application, same trees and same butterflies, only their heart rate did not control the butterflies and it did not appear on the screen. We measured heart rate and thus stress via an Apple smartwatch 4 times. 5 minutes after arriving, directly after our first battery of memory test, directly after our intervention, and directly after our second battery of memory test. We also measured mood, pre and post experiment with a subjective Brunel mood scale. For measuring memory, we measured visual working memory with our colored block matrices task, and declarative long-term memory with our word pair associate task. Across the board, none of our results were significant, so we'll just discuss the trends that we saw. For our working memory, even though there was a significant difference in groups at baseline, there was no significant difference from pre to post for the biofeedback or the non-biofeedback groups. For the declarative long-term memory, we did approach significance and saw a trend of an increase in accuracy score for our declarative long-term memory measure for our biofeedback group, while we saw no change in our non-biofeedback group. For our measure of mood, we looked at the average change from pre to post, and we have our p-values here. Some that approached significance were anger, tension, and fatigue. We're very encouraged by the results and the trend, and we're very excited to look at it with a larger sample size. For our heart rate, we could see that from our baseline to after our first battery of memory tests for both groups saw an increase in heart rate, which is not surprising. They both saw a decrease in heart rate after our intervention, and from after our intervention to till after our second battery of memory tests, it's difficult to tell what that trend looks like. So in conclusion, again, our small sample size and group differences at baseline across the board limited the interpretation of our findings. But we are very much encouraged by the declarative long-term memory and multiple Brunel mood scores that did approach significance. It's just that we're underpowered. So for future directions, we'd love to add a control group that has no augmented reality. And just out of my own curiosity, if we found significant results for the addition of biofeedback, I would throw in a measure of locus of control, wondering if the significance could be sort of mitigated by a temporary boost in feelings of an internal locus of control. Okay, and that's it.
Okay, great. Thank you very much. Ray, any questions? I see everybody's making good use of their hand emoji, clapping. Any questions? I was wondering about the heart rate variance. Since you have within person controls, if you use the variations in the own person's heart rate, you would kind of lower your standard error bars, right? Because, you know, one person might have a low heart rate and another person, they seem kind of high. Are people nervous doing this? And also whether you could use in-person controls to get a kind of a smaller variation.
Yeah, we sort of struggled with that across the board. The students just appeared to be very nervous, and it was also during finals week. And then I'm not certain what kind of controls that I would use for in-person. But I'm very much open to ideas.
You could say change in heart rate from baseline, like some people might have a resting heart rate of 80. Some people might have 60. Some people might have 100, and that gives you a lot of variance across subjects. But you could say change in baseline, change in heart rate. So this person has 100, and then now it's 80, so that's minus 20%. You know, whereas another person starts at 60 and goes down to 50, that's minus 12%, like that. You know what I mean? So you know, kind of change according to their own person's physiological measures, as opposed to looking at variance that's just between people, you know.
Yeah, I'm writing that down. I definitely, if we hopefully pick this up again, I would love to look at it that way. Thank you.
Is Claire here? Claire?
Yeah, I'm here.
Yeah, oh, there you go. One of the big advantages to Zoom is there's names on everybody's, so we all know who each other are.
Yeah.
Okay, Claire Brinkman, you want to, so Ray, I think you have to stop sharing.
Okay.
And Claire, it's your turn. You want to give us your presentation? I'm going to see.
I was muted. Can you all see that?
Yes, we can.
Awesome. Okay, cool. Okay, hi, I'm Claire Brinkman, and I did my thesis with the Social Cognition Lab, and I was advised by Sarah Hodges and Ruth Ellingson. So in the past, a lot of social psychological studies of perspective taking involve experimental manipulations, meaning that participants were either told to take someone's perspective or not. Often they were assigned a narrative about someone's life, typically someone disadvantaged or experiencing distress. And perspective taking has often been linked to empathic emotions and pro-social outcomes in those studies. So though these studies are very informative, they don't tell us a lot about how participants and people in general perspective take on their own. So our study is exploring naturalistic self-reports of perspective taking in order to address how and when people do it. So to answer this question, we conducted an online survey as part of the general survey, and we got 217 participants, and yeah, they were completing it for partial fulfillment of a class requirement, as they do for a general survey. And they all responded to a prompt of, think about a time, preferably in recent days, when you were aware of trying to take another person's perspective. And then they were given a text box and allowed to respond without any word count or time limits. And then the resulting responses were coded for whose perspective was taken. So this could be maybe their roommate or their friend, professor, someone they're close to, or it could be an aggregate group like people experiencing homelessness, or a political party as a whole, or just someone with a different viewpoint of them as a whole. And then we looked at, within these narratives, also what triggered the perspective taking. So this could be a recent breakup, or trying to understand the mistreatment of another person, or taking someone else's perspective in order to understand how their classwork will be evaluated. And then we looked at how people tried to accomplish this task. So if they mentioned any strategies. For example, in past research, there's a lot of manipulations about assigning people either to imagined other conditions or imagined self conditions. And so we were curious about the usage of those. And then we're also interested, of course, in the outcomes of the perspective taking. So if they do result in pro-social outcomes, as they tend to in manipulated research. And then, because we can't really seem to talk about perspective taking without using metaphors like walk in their shoes or see it through their eyes, we also coded for instances of this. And then the way we did this is we had 2 coders go through all of them, and we achieved 88% agreement on all of the coding categories. And then any disagreements between coders were resolved through discussion. Yeah, so then our results can be seen here down on the pie chart, and we'll just start with the one on the left. And interestingly, we found that triggers for perspective taking most commonly were reported as disagreeing with another person, questioning their behavior, or being curious about their experience. And past research has manipulated this to be someone experiencing hardship or misfortune. And so we found that in daily life, people tend to be motivated by disagreement or kind of general confusion. Yeah, and then also in the method that participants used, we found that people use imagined other quite almost more than twice as much as they use the imagined self condition, whereas in manipulated studies, they're often assigned 50-50. And this could be because imagined other conditions have been shown to cause distress for the participants. So people could be taking a half step back here. And then we found for whose perspective was taken, that people most commonly take the perspective of people they already know, but more specifically, people they're quite close to, like friends or family or romantic others. And then also we found that 38% of participants use at least one metaphor when describing their perspective taking. And overall, despite the prevalence of empathic emotions and pro-social outcomes associated with manipulated perspective taking, in our study, we found that only 18% of our participants reported feeling empathic emotions as a part of perspective taking, and the majority, 74%, didn't report any specific outcome as a result of their perspective taking, meaning they didn't mention in their narrative what all this amounted to for them. So taken as a whole, our results suggest that manipulated and naturalistic perspective taking may differ in important ways, and accounts of naturalistic perspective taking highlight that disagreement with another person can be a common trigger, and there's definitely more research to be done about the effect of perspective taking when there's the context of a disagreement. So yeah, as a whole, we now understand that there's a lot to be learned from naturalistically studying perspective taking. Yeah, thank you.
All right, thank you very much. Anybody have any questions?
Yeah, I think this is really interesting. And I was just wondering if you found, especially when you were looking at like different metaphors or phrasings, and if you found any particular metaphors or phrasings associating with like particular subjects of like whose perspective people were trying to take, or particular triggers or situations, if you found any of those tending to go hand in hand.
Yeah, that would be really interesting to look at in past research, but for ours, because it was just an exploratory study, we didn't have any hypotheses, so it wasn't really appropriate for us to conduct inferential statistics that would look at like those correlations. So we didn't look at that, but that would definitely be very interesting to look at. Yeah, we definitely found that people use visual metaphors, like see it through their eyes, much more commonly than the shoes or the place metaphors. Yeah. Thank you.
Any other questions? Thank you, Claire, for a great presentation.
Thanks.
Could you, unshare your screen?
Mm-hmm.
All right, Jingjie Lu, it's your turn to give us your presentation.
Hi, yes, I'm ready. Sorry, can you guys help me to let me show my screens to you guys?
You should have the ability to share your screen. You see the little button down at the bottom that says share screen, the green one?
Oh yeah, I see that.
Okay, click that.
Yeah.
Then it should be able to just say desktop. It's probably the best option.
There we go.
Yep. And now you can.
Hi, folks. Welcome to this. So today I'm going to talk about my research topics, which is also the title on my poster. As you've all said, the parent stress correlated with child cognitive ability. So as we all know that the early childhood is the critical time period for children to developing their cognitive development. And so I'm interested about like if the child has been exposed to some stressful circumstances from there, which we know is mainly from the parent's stress level. So that's going to affect the children's cognitive ability development processing. So with that, my hypothesis will be that the higher level of the parent's stress will going to cause the lower level of children's execution functional and the languages development processing. So the test administered to address children's cognitive executional functionals by using a game which we call the EF Touch. So I've also marked it down over there as you we're going to see. And also we're going to test the children's languages development by using a game which we call the quiz. So which we can test the children's vocabulary, syntax, and languages learning parts. And for parent stressful levels, we're going to using the parent stress index short form to test the parent psychological text levels. But from the result, the surprising, the results then tell us from what we have assessed is that the parent stress level, actually you can tell from the tables over there, has not significantly correlated with the children, nor with the children's executional functions, nor with the language's development process. So which means is the stress does not support our hypothesis. However, we found something surprising that the parent's stress is only correlated with the children's gender, and the children's EF Touch, the execute functional scores is correlated with the children's languages development processing. And that is the surprising found, but which is not, again, what we expected to see. So I've listed 3 effective reasons that may cause the way we got this results like that. So the first reason is maybe when we, like during the experimental processing, when the parents are asking for filling the questionnaires, and the environmental may get infected the parents. So for example, they carry this, or the parents may get not familiar with the environment, for example. So that may cause the parents did not feel good with their stress level questionnaires. And also it may cause by the experimenter has not strictly to control the time and the protocol when the children has been done those 2 kind of tests. So that's may also another 2 reasons cause the we didn't got the significant reason of there. So with the next steps of my research, if I would have the processing to do that, I may gonna to retest both the parents' stressful levels, nor I'm gonna to like strictly controlling children's, like when they are doing the EF touch nor the quills. So hopefully we could get all those. And also I may gonna to change the hypothesis, because we are gonna to say the correlated. So maybe the parent stress is not directly to correlated with the children's cognitive ability score, but the way how children are gonna to express their cognitive ability. And that's all.
Okay, thank you very much. Anybody have any questions? Well, if there's no questions, we'll move on to the next presentation. Tillena Trebon, Zoe, Allegra, Maggie, you guys ready?
Yes.
All right.
Thank you.
Take it away.
All right. So our research is looking at the competitive relationship between linguistic perception and production when learning a new sound contrast. And we were advised by the lovely Dr. Melissa Bays-Burke and Dr. Zach Jaggers at the U of O Speech Perception and Production Lab. And I also just want to say it is so fantastic and inspiring to see other women in STEM and research. I love to see it. All right, so our research investigates the connection between perception and production when learning to discriminate between unfamiliar sounds. It is commonly assumed that humans use the same neural mechanisms for recognizing a spoken sound and producing a sound. So if this assumption is correct, when we get better at perceiving sounds, we should also get better at producing sounds, and vice versa. However, recent research indicates that the relationship between perception and production is complex and possibly competitive. Take it away, Allegra.
Oh, sorry. To answer these questions, 20 participants were trained on a new sound contrast over the course of 2 days. The new sound contrast contained dental retroflex sounds from Hindi and had 6 steps on the continuum from one sound to the other. The first 3 sounds on the continuum are dental sounds, which are made with contacts between the tongue and the teeth. The last 3 sounds on the continuum are retroflex sounds, which are made with the tongue pointed towards the back of the mouth. Most native English speakers cannot distinguish these sounds before training. Each day, subjects participated in a pre-test, a training period, and a post-test. Training pre-tests and post-tests consisted of ABX tasks where the participants heard 3 sounds. The first and the second sounds were distinct from each other. The third sound was either the first or the second sound replayed. The participant had to determine whether the third sound was the first or the second sound. During the training period, participants were told whether their selection was correct. During pre-test and post-test, the participants were not told whether their selection was correct. The experiment had 2 conditions. In the perception and production condition, subjects produced the sounds during training after each ABX task. In the perception-only condition, Subjects did not. Scores on pretest and posttest were compared to determine how well subjects had learned the sound contrast.
So what our research is asking is if linguistic perception and production utilizes the same neural processes, and whether or not someone gets better at perceiving the difference between two sounds by producing them. And with the answers to these questions, we hope to uncover and better understand the neural underpinnings of linguistic perception and production, especially in the context of language learning.
Okay, so now we'll discuss the results from the graph. So we can see the day one pretest and day two post-test scores for the perception and production participants on the right graph, and the left graph shows these scores for the perception-only subjects. And then the blue lines represent the pretest scores, and the red lines represent the post-test scores. The y-axis on both graphs represents the percent of the participants' correct answers for the ABX tasks in the pretest and post-test. The x-axis on both graphs shows which sounds on the contrast continuum the subjects heard. So like Allegra said, the numbers 1 through 3 represent the category of dental sounds, and 4 through 6 represent the category of retroflex sounds. If the subjects successfully learn the sound contrast, we would expect to see a large peak in the middle of the plot where the categories of sounds are different. So in the perception-only graph, the post-test scores are higher than the pretest scores, which shows that the perception-only participants showed improvement in learning the sound contrast. Furthermore, we see a peak in the middle of the plot in sound pairs 3 and 4, which indicates robust learning between sound categories. However, in the perception and production graph, the post-test scores are not higher than the pretest scores and are lower in some of the sound pairs, which shows that these participants did not learn the contrast as well as the perception-only participants. Our research demonstrates that the relationship between perception and production is competitive.
Our research challenges traditional assumptions about linguistic perception and production by showing that the relationship between perceiving and producing new sounds is competitive. Our research reveals that producing new sounds while learning to discriminate between those sounds hinders perceptual learning. These results show that linguistic perception and production may not utilize the same neural mechanisms. This experiment informs second language teaching methods. Our results show that teachers should incorporate a curriculum that allows students to take breaks between learning to perceive and produce words and sounds. Understanding the relationship between linguistic perception and production is essential for optimizing second language teaching methods and for understanding how humans acquire language. Thank you all so much.
Thank you all for an excellent presentation. So open it up for questions. Anybody have any questions?
In addition to allowing for breaks, would you have any other recommendations for educators of a second language?
That's a great question. And like Zoe said, we are conducting more experiments with the lab to better investigate the connection between perception and production more. And I'm sure Zoe is happy to talk you through some of those conditions.
Yeah, so we'll be doing additional conditions such as playing white noise when subjects are producing the tokens to see if it's the actual, the auditory feedback that is disrupting their learning. So when they're learning a new sound contrast, they may be incorrectly producing the token. So by covering their ears with the white sound, they won't be able to hear themselves and they might show improvement in learning. We will also be doing a low and high math condition. So in this series of studies, we'll manipulate the cognitive load and we'll have the participants solve 1-step and 2-step math problems in the perception only condition. So if listeners are showing a disruption of perceptual learning under these conditions, it would suggest that an increase in the cognitive load may be responsible for this disruption in perceptual learning rather than just production itself.
Yeah, that'll be really interesting to see.
I also just wanted to note that in addition to second language classrooms, our research could have potential impact for the field of speech-language pathology. Understanding the relationship between perception and production could be really important for the rehabilitation of different language disorders. So by understanding the relationship, we could potentially improve therapeutic practices.
I have a question. People that are deaf and use sign language, do they also have a motor theory of language perception? Do they have to sign in order to learn a new language?
That's another great question. And I think there's a project going on that I think Dr. Baes-Burke has mentioned in the past that's looking at investigating that, and that's a future direction. Yeah, I don't think much is known about that. It's a great question.
All right. Any other questions? Any general questions? Anybody want to ask any questions of any of the other speakers? I would like to say that the University of Oregon is trying to make a new Women in STEM academic residential community. And the main thing we need is someone to be the director of that. And we're talking to someone in neurobiology right now, but she's not sure she'll have the time to do it. What we need is a faculty member that's willing to use one of their course credits. Biology department, for example, has allowed whatever faculty member does it to be excused from one course teaching, and they would use that course credit to run the academic residential community of Women in STEM over the course of the year. I don't know if you're familiar with ARCs, you probably are, but you know, we're hoping to form one around that topic. So if you know of anybody, any faculty that would be interested in taking that up, please let me know. davidmc@uoregon.edu. All right, well, thank you all for great presentations. I'm sorry it had to be virtual, but we're starting to get back to research soon, and hopefully you'll be able to get back and finish your projects, and hopefully next year we'll be able to do this in person. Okay, thank you all very much again, and you all gave great presentations. Take care.
Thank you.
Thank
Thank you.
Thank you for
Bye,
hosting us.
everybody.
Thank you, everyone.
Have a good day.